Hi, in this video, we're going to look at the Chapter 15 example on marketing mix models. So in order to do that, we're going to first go over into R, and we're going to bring in the data and analyze it and build our marketing mix model. Once we have that, we'll predict the expected quantities of our sales, and we'll go over into Tableau, and then we will visualize some of the results. So let's go ahead and go into R to start. All right, so the first thing we're going to do is open up the file, the script. In this case, it should be called marketingmix.r. Let's go ahead and make it a little bigger so we can see it. All right. So as usual, the first step we're going to do is look to see if there are any packages we need to install to do this analysis. It turns out for this analysis, we're going to need the package called T-Series or Time Series. So let's go ahead and install that package first. We'll select the cloud. So once that's been loaded up, now we can load the library for the T-Series and set our random number generating seed. Okay, next step, we're going to bring in the data that we're going to analyze. So we have data that is from our firm, and it's going to look at our sales of HDTVs on a daily basis over 2 years. So let's go ahead and load up that data. So we're going to read in a file called marketing mix, mmix_data. Okay. As per usual, if we want to see a little bit of the data, we can click over in the console window, type head mmix, and we'll see the first 6 rows of data. Here we see the day. This is the date. So the date starts with January 1st of 2018. Quantity represents the number of units we sold, in this case, HDTVs. Price is the average price of the TVs that we sold. Revenue is just going to be the multiplication of quantity and price. And then we have how much money on a given day we spent on our digital advertising, our digital search, our print advertising, and our TV advertising. Right? So that's what we have in our data. And what we want to do is we want to figure out how perhaps the price and our advertising spends are impacting our ability to sell HDTVs. So the first thing we might do is maybe look at some descriptive statistics of the data, right? So this next function is just this lapply, sapply function is just going to print out the mean of each of the variables in our data set. Now, some are less interesting. For instance, day is just a count from 1 to 2 years. So the average between that is 366. We cannot take the mean of a date, but for all these other variables, we can see on an average day, we sold around 114 HDTVs on an average price of $326. So our revenue on average was about $36,000 per day. We spent around $2,300 or a little more than that on digital advertising, about $1,800 on digital search, about $375 per day on print, and about $8,000 per day on TV advertising. So what we want to do now is begin building our model so that we can understand the relationship between our price and our marketing efforts on our sales. Now, when we do marketing mix models, it's often the case that we look to try and build what's called a multiplicative model, which means we'll take the log of quantity and we'll take the log of the explanatory variables so that we can measure what are called elasticities or calculate the elasticities. So to do that, we're going to create some new variables. These are just going to be the log variables. So this is log of quantity, log of price, and so on. We're also going to take the lag of quantity, the lag of log of quantity, because we want to control for yesterday's sales, which kind of captures everything that happened in the past to some degree. And we're also going to create a set of dummy variables for days of the week to see if different sales happen on different days of the week, right? Maybe on certain days, people are more likely to shop at our retail outlet. So we'll go ahead and create these variables. Now, before we run our model, we're going to do two things. The first thing we're going to do is we want to see whether or not yesterday's sales are too predictive of today's sales. Essentially, it's something called a unit root problem. If yesterday's prediction, or if yesterday's sales almost perfectly predict today's sales, essentially the coefficient of that AR1 type model is 1 or no different than 1, then we might want to take the change or the difference between those variables and use our marketing, look at our price and our marketing efforts around how much do they influence the change of sales day over day. If we don't have a unit root problem, we can just put the lag of quantity in our model and control for yesterday's sales. So that's what this first test is. It's the augmented Dickey-Fuller test, and it's going to check to see whether we have a unit root problem. So we'll go ahead and run that. So here we see it's significant, which means we don't have a unit root problem, right? It means it's significantly different than 1 or the coefficient of 1, meaning that we have what's called a stationary series in the sense that we can control for what happened yesterday, but that yesterday's sales aren't a perfect predictor of today's sales. So we're going to go ahead and not difference. We're going to keep quantity as our dependent variable, log of quantity, and we'll take the lag of log of quantity as one of our x variables along with our other variables in our model. The next thing we want to do is check for multicollinearity. Now, multicollinearity among our x variables is problematic in that if they are too collinear, then you run into issues of biases that show up in your parameters that you estimate. So we're going to check to see if any of our x variables are too correlated with each other and then deal with that problem if they are. So this will just run a correlation table. So here we can see the correlation between our variables we're going to put in our model. Now the diagonal of a correlation table is always going to be 1 because, for instance, log of quantity is always going to be perfectly collinear correlated with log of quantity. What we're more interested in is the off diagonal. Now, certainly we like this column. So this is the what's correlated with our outcome of interest. We want these to be pretty correlated because this means they're doing a good job of explaining the outcome of interest. What we're more interested in is looking at the stuff over here and seeing what is correlated in terms of our x variables of our marketing mix. Now, price tends to be pretty correlated with a lot of things. Not terrible, although it's somewhat correlated because prices are usually strategically set based on other actions that we take. But nothing is too high that we want to necessarily deal with it as being a multicollinearity problem. We do see among our other variables that digital ad spend and digital search are pretty correlated. And the reason for that is probably whoever controls the spending in those channels is probably making that decision on each of those spends at the same time, in which case that the decisions are probably pretty correlated with each other. So in this case, we don't want to put both of those variables in the model because they'll fight over the same thing. So what we're going to do, one option would be to drop one of the variables. The other option would be to combine the variables. So what we're going to do is just combine them together. And so our next step is we're going to create a new variable called digital, which is just going to be the sum of spending in the ad channel and spending in the search channel. And we can see other than that, none of the other x variables seem to be too correlated. So this is the only issue we need to address in terms of multicollinearity. So now we have that variable called digital, which is just that sum of the two digital spends. So now let's go ahead and run our log-log regression, right? This is run as a linear regression. Our y variable of interest is the log of sales quantity. We're controlling for the yesterday's sales quantity. We have price, log of price. We have log of the digital variable we just created, log of print, log of TV spend, and then we're going to put in the dummy variables here for each day of the week. We're just going to take one out, right? We only need 6 out of the 7 dummy variables. So we'll go ahead and run this regression and print out the results. And what do we see here? Well, we see that, for instance, some of the days of the week are significant. For instance, Sunday is negative, meaning that on average on Sunday, we sell fewer, all else being equal. We see that Tuesday seems to be positive. So for some reason on Tuesday, on average, our sales are a little bit higher. So we're controlling for that. The parameters of interest, though, are we do see that there's pretty significant sales yesterday. It's not 1, but it's 0.7 is pretty high, meaning that there seems to be inertia day over day. Price is negative and significant, and it's between 0 and -1, meaning we have some inelasticity of our price, right? So if we increase our price on average, we'll see a decline in sales at a lower rate. A 1% increase in price leads to a 0.5% decrease, 0.56% decrease in sales. Right? We see that digital, print, and TV here are all positive, and TV is a moderately significant. Digital and print are more significant, but in all cases, we see that spending in those channels seems to drive up sales, which is good. Again, these can be read as elasticities. So a 1% increase in digital spend leads to a 0.09% increase in sales. Okay. We also see overall, we have a pretty good model fit, 0.74. So 74% of the variation in our outcome is explained by our variables, which is good. So what we're going to do now is we're going to go ahead and predict quantity sold for each of the days, and then go over to Tableau and visualize some of these results. So our next step is to create a variable called predicted quantity, which is just going to be, remember we took the log of quantity, so we're predicting log quantity. So we're just going to take e to the power of our prediction to get predicted actual quantity back. Okay. The last step is we're going to export the file, and we'll call it mmix, marketing mix _ predicted. And that's going to be what we take into Tableau to do some visualization. So mmix predicted.csv. Okay, so now we're going to shift over to Tableau to do our visualization. All right, so the first step here is going to be opening up that file we just created. So that's that mmix predicted file. All right, we see the data pop up here. We scroll to the right. We see these are the log variables we created, and we have our predicted quantity at the very end. So let's go ahead and open up sheet 1 to start. Now, the first thing we might want to do is Tableau does a very nice job. We saw the means of the different variables, the X variables we used. Tableau can also show us how they vary over time. So one thing we could do is we could drag the date over to columns. Now it'll make the assumption maybe that we want to aggregate the dates by year. If we want to look more at a granular data, we can hit the drop down here and choose day, in which case now it's going to give us at a daily level what's going on. And then we can go ahead and drag over some of our different variables. So we have digital ad, digital search. We have print and TV. These are our spending variables that we can put in. We can also drag price over here. So that pops in. So now what we have is we have a visualization here of the average daily spends in all of these different channels. This is digital ad, digital search, print, and TV. And then we also have the average prices of our sales. So we can see here the variation. It looks like we ran, this is probably a Black Friday campaign that we ran on the digital space. We see a big spike in our spending there. Again, it happened the following year. Print, we see that the way this works is we spend for a month and then we divide that by 30. So you can see this month, the average spend was the total month over 30, and then it drops to this month and up and so on. So that's what we see with these different plateaus. For TV, we see sort of a little variation day over day. We see some spikes around the holidays seasonally. We see some summer spikes. So maybe there's a belief that more sales happen during those times. And we see, in general, pretty stable prices. A few times we see some price discounts happening, but in general, we have fairly stable prices over time. So this is just a nice representation of the variation in our spend and our price over time that can be helpful in us understanding what we've been doing for the past few years. So let's go ahead and retitle this. So we're going to call this just the marketing spend and pricing over time. All right, so that's one nice visualization. So let's go ahead and look at our predicted versus our actual. Maybe that'll help us see how good our model is fitting. So we'll go ahead and open a second sheet down here. So in this case, again, we can drag the date over to the columns, and we'll again maybe choose by day. And here what we want to do is we just want to see how good our model is fitting. So what we're going to do is we'll first drag over the predicted quantity that we got out of our model. And we can see by day what our predicted quantities were. And we can drag over our actual quantity, right? That's this quantity variable. Now it'll create two charts. If we want to overlay the two charts, we can click on this down arrow of the quantity and choose dual axis. Now they're on slightly different scales. So let's go ahead and right click on the axis and choose synchronize. And when we do that, what you see here is, in fact, our model's doing a pretty good job of actually predicting where the blue behind is the predicted quantity and the orange in front is the actual. And we can see the blue sort of tracks pretty well. If you want to see it the other direction, you can drag this to the other side and you'll see the blue line come forward, and you can see the blue line traces pretty well over this orange line. So let's go ahead and name this. So we'll double click there on the sheet and we'll call this predicted versus actual quantity. So it seems like our model is doing a pretty good job of actually predicting our sales given our prices and our previous day's sales and our marketing spends in these different advertising channels. So the last thing we can do is we can actually do the same thing for not just quantity, we can do it for revenue. So if we click on creating a new sheet, we can do that. Now, in order to do that, we didn't predict revenue yet, but we can create a calculated field that will do that for us. So if we go ahead and choose analysis, create calculated field, so we'll create a variable called pred revenue. And in this case, we know the predicted revenue is just going to be our price times our predicted quantity. Say OK. So now we have pred revenue here. So let's go ahead and drag date over to columns. We'll switch it to daily. Then we can bring pred revenue over, and we can bring actual revenue over. Right? Again, if we want to overlay these, we can hit the drop down and choose dual axis. We can synchronize them. So we'll go ahead and right click here and choose synchronize axis. Right? And here again, we see that our revenue seems to be going over this red. If we want to see the predicted revenue in the front, we can just switch and drag this to the other side. So now we see the red in front. So again, our predicted revenue seems to be tracking pretty well with our average revenue over time. So let's go ahead and name this predicted versus actual revenue. So what you saw from this example is you saw that we can take the marketing advertising spend data, the pricing data. We can also build models, marketing mix models with other of marketing mix variables. And once we sort of go through our checks, check to see if there is a unit root problem. We check for the multicollinearity issues among our X variables. Once we do those things and build our model, we can predict both, in this case, quantity and revenue, and we can visualize that to see what's happening with our data and how good our model is at capturing that. So let's go ahead and just save our workbook here. So we'll say save as. We'll call this marketing mix. And again, we'll save it as a Tableau packaged workbook so that our data is included in this workbook. And now we've done our marketing mix example from chapter 15.